This is an excerpt from the book Man and Microbes by Arno Carlin regarding Lyme disease. In 1975, two mothers in Old Lyme, Connecticut, concluded that something strange and dangerous had struck their families. Each had a child suffering long, recurrent bouts of fever and aching joints. They were diagnosed with juvenile rheumatoid arthritis, in which the immune system attacks joints as if they were foreign bodies. Although rheumatoid arthritis is rare in children, and these two had some atypical symptoms, no alarm went off in their doctors' minds. The mothers did become alarmed when they learned that a dozen other children in the area had the same problems in diagnosis. That seemed to defy probability. Fearing an infection or environmental toxin, they called the state health department and the Yale Rheumatology Clinic. Juvenile rheumatoid arthritis is not infectious, they were told, and does not occur in clusters. A dozen cases in Old Lyme would mean that it was occurring there at thousands of times its normal frequency. The Connecticut children had all fallen ill in summer, in a suburban setting. That suggested an arthropod-borne disease, but their symptoms matched no known infection. Dr. Alan Steer, then of Yale, led a team that surveyed the adjoining towns of Lyme, Old Lyme, and East Haddam, seeking similar cases. The syndrome, they found, had afflicted 39 children and 12 adults in the past 3 years. In 1977, Dr. Steer published a description of a disease he called Lyme arthritis. It had the hallmarks of an infection, although no microbe yet had been found. Many patients had developed a rash when the illness started, and several recalled having been bitten by a tiny tick where the rash began. Fortunately, one of them had saved the offender and turned it over to researchers. It was Ixodes scapularis, formerly called E. damini, the deer tick. Field workers began collecting ticks around Old Lyme to see what germs they were carrying and to study the tick's life cycle. Deer tick is a misleading name. The deer is merely a brief feeding and mating station at the end of I. scapularis' two-year existence. The tick hatches in spring as a 6-legged larva the size of a pinhead. It feeds mostly on rodents, especially the white-footed mouse, from which it acquires the Lyme microbe. Over the winter, the larva changes into an unlovely 8-legged nymph. Still carrying microbes from the previous summer, it passes them to almost any warm-blooded host it finds: raccoons, squirrels, skunks, birds, or humans, but its favorite is still the white-footed mouse. At summer's end, the nymph becomes a tick, smaller than a printed period. This is when it eats its last supper and finds its mate on the body of a deer. For lack of a deer, it may attach itself to a cow, horse, dog, cat, or human, and pass on the Lyme infection. All of these hosts suffer fever and arthritis as a result. The germ was discovered in 1981 almost by accident, after Rocky Mountain spotted fever broke out on Long Island. The appearance there of this infection was less odd than its name suggests. Rocky Mountain spotted fever first reached humans late in the 19th century in Montana's Bitterroot Valley, killing up to 80% of the infected. Most victims were prospectors, miners, and settlers. Having deforested large areas, they worked in the resulting scrub landscape and caught from wood ticks a rickettsial organism related to the one causing typhus. The germ and its vectors are now widespread. Rocky Mountain spotted fever, which has a natural reservoir in small rodents, occurs from Canada to Brazil. Outside the Rockies, it is usually less virulent, but still dangerous. A similar disease, ehrlichiosis, common in dogs and transmitted by the brown dog tick, first appeared in humans in 1986, and in some areas is more common than Rocky Mountain spotted fever. The CDC carefully monitors such infections as Rocky Mountain spotted fever and ehrlichiosis. So when Rocky Mountain spotted fever surfaced on Long Island in the 1970s, biologists sought the source of the outbreak by collecting ticks there. The specimens were sent for study to a public health service laboratory in Montana that was experienced with tick-borne diseases. There, Dr. Willy Bergdorfer dissected the ticks and cultured microbes from their bodies. In the deer ticks, he noticed an unfamiliar member of the Borrelia family, a pale, slender spirochete related to the syphilis germ. He injected it into rabbits, and they developed the symptoms of Lyme disease. Bergdorfer received the reward of those who discover new species. The bacterium was named Borrelia burgdorferi. Although its cause is known, Lyme disease remains a diagnostic nightmare. Remember, this was written in 1995. Only half of its victims show a telltale bullseye rash at the site of the tick bite. Most develop fever, headache, sore throat, nausea, fatigue, swollen glands, stiff neck, and aching muscles. At this point, they may be diagnosed as having anything from flu to rheumatoid arthritis. A dozen laboratory tests for B. burgdorferi exist, but all can give false results. Many patients recover within days or months, even without antibiotics, but some become chronically ill. The spirochete can change its surface proteins to evade both drugs and the immune system. It is unclear whether symptoms sometimes persist because the germ hides in cerebrospinal fluid or because it sets off autoimmune responses that outlive the infection. Like syphilis, Lyme disease can subsist during long latency period and then reappear to attack the joints, heart, or nervous system. Long-term cases present a bewilderment of symptoms that last for years. The arthritis can become so severe that it requires knee surgery. Heart damage may necessitate implanting a pacemaker. There can be such neurological complications as impaired memory, meningitis, or facial paralysis. Lyme disease increased 20-fold over a decade, from 500 new cases in 1982 to 10,000 in 1992. It became a staple subject of television, newspapers, and news magazines. In hard-hit areas, fear turned into hysteria. The reaction was understandable. Lyme disease was increasingly common, often misdiagnosed, sometimes crippling, and it could drag on for years. Even where it was not common, many parents fearfully kept children indoors during the summer. The prevention and treatment of Lyme disease became an industry. Stores and mail-order companies peddled tick repellents and home diagnostic kits, none foolproof and some probably of little use. Despite people's precautions, Lyme disease continues to become more common and widespread. It has appeared in almost every state. The greatest number of cases occur in the Northeast and upper Midwest and on the West Coast. Some experts believe it is overreported, others that it is underreported. Even if underreported, it is now the most common arthropod-borne disease in the United States. Lyme disease is not, in strict terms, brand new, but it is novel as an epidemic. When Bergdorfer discovered its cause, he recalled a lecture he had heard decades earlier about a similar, milder condition reported sporadically in Europe. In Germany in 1883 and then in Sweden in 1910, doctors had described a rare skin disorder that sometimes caused neurological complications, including stroke. They suspected it was carried by ticks. Bergdorfer correctly guessed that these reports of erythema migrans traveling rash were early, scattered cases of Lyme disease or something like it. Still, it was puzzling that the infection had suddenly become severe and epidemic in the United States, with arthritic symptoms rarely seen in Europe. Clues to how and when the disease had spread might lie in tick collections in science museums. Even in ticks pickled in formaldehyde for decades, tests could detect remnants of spirochete's surface proteins. Traces of B. burgdorferi showed up in ticks collected on Long Island in the 1940s and in other pre-1975 specimens from Cape Cod and Wisconsin. In Montauk, in the eastern tip of Long Island, people had spoken for years of an arthritis they called Montauk knee. It turned out to be Lyme disease. Clearly, Lyme disease had been around in this country for decades before 1975, undiagnosed or misdiagnosed. It, or a precursor, had existed in Europe, but it became epidemic only when changed environments and new lifestyles offered the microbe a new opportunity. The reason was not that people were exploiting the landscape, but that they were helping it to recover. We saw earlier that what European explorers found in the New World was not virgin forest. For millennia, Native Americans had hewn, burned, and planted reduced first-growth woodlands in the Northeast. Then, for 3 centuries, white settlers sacrificed forest for farmland, timber, and fuel. By the 1800s, the East was almost treeless. This, as much as hunting, brought deer and their predators to the brink of extinction. During the 19th century, agriculture shifted to the Midwest. Farms in the East shrank in size and number. Land began reverting to scrub and regrowth forest. At the turn of this century, federal and local governments acted to preserve and restore vast tracts of land. Forest and wildlife rebounded. Patchy new woodland is ideal for deer. They thrive best at forest's edges. By 1900, the deer population of the East was recovering. The populations of predators such as wolves, bears, and big cats were not. The recuperating landscape allowed a resurgence of other wildlife, including rodents and ticks. And it drew another species, humans, eager to flee crowded industrial cities. Urbanites who had never seen true wilderness mistook second and third growth woodland and scrub for forest primeval. They didn't really want raw nature anyways. They sought a touch of nature along with urban amenities. The result was a compromise, suburbia. At the end of World War II, the East had several times as much forest as a century earlier. The deer population was exploding. All over the country, an urban housing shortage and the post-war economic boom combined to create vast swaths of suburban and semi-rural housing. Deer adapted to them as resourcefully as squirrels and raccoons. Today, deer crop the grass in suburban yards, loiter in city parks, and are common highway hazards. Many exasperated homeowners and motorists regard them as vermin and refer to them as rats with hooves, especially where Lyme disease is rampant. People are learning that a convalescent environment creates its own peculiar problems. Ecological change of any kind creates a risk of human disease. Since the 1980s, similar regrowth has increased in Europe, with flourishing deer, rodents, ticks, and suburbs, and big outbreaks of Lyme disease. Europe now has twice as many cases as the United States. Germany alone has tens of thousands each year. Lyme disease has been reported also in Japan, China, Australia, and South America. This may be just the start of its story as a global epidemic. We still have much to learn about Lyme disease. Biologists suspect that it is spread to new areas by ticks migrating on birds. It is not certain why the European form is milder or why it tends to cause neurological rather than arthritic complications. Perhaps each strain of the germ has adapted to a different vector, developing a slightly different characteristics. In Europe, Lyme disease is caused by the sheep tick. In California, its life cycle involves the dusky-footed wood rat and 2 species of tick, other than I. scapularii. Prevention and treatment remain problematic. There is an effective vaccine for dogs to reduce transmission to pet owners. Vaccines for humans are still being tested. Antibiotics may help many patients, but sometimes they cannot wipe out the infection. The best protection is still using repellents, examining people and pets for ticks, and seeking prompt attention for tick bites. Recovering woodland has given humans another tick-borne disease. The Babesia parasite, a protozoan that invades red blood cells, causes a malaria-like illness in cattle. On Texas ranches, where it used to do great damage, it was called red water fever. It was never known to infect people until 1957, when sporadic cases appeared in Yugoslavia and then on Nantucket Island. an old whaling center off the Massachusetts coast. On Nantucket, as in most of the northeast, forests and deer have almost vanished by the 19th century. The trees had been felled to create grazing land for sheep. The sheep reduced the island to a close-cropped pasture, eliminating the problem of deer and ticks. Hey guys, stop it please. Then pine trees were planted as windbreaks, sheep farming and whaling declined, and cranberry farming and summer tourism took their place. Scrub and new forest appeared. In the 1920s and 30s, deer were reintroduced, perhaps to give wealthy summer homeowners an illusion of untouched nature. Deer ticks returned and replaced local tick species. Thus arose a mixture of forest, wildlife, and urban escapees that made Lyme disease epidemic. It gave a new home to babesiosis as well. Babesiosis is usually less severe than Lyme disease, but it can be chronic and dangerous, especially to the elderly